So we are given functions f, g, and h are twice differentiable. That's just their way of saying there aren't any issues. If they're differentiable, they're also continuous, which is going to come up, the continuity thing, because we're asked about continuity in question D here. So that is going to come up. So they're differentiable, nothing's the matter. G of 2 equals h of 2, which equals 4. All right, that means that the point 2, 4, 2 comma 4 is on both of those graphs. So that point exists. If you input 2, you get back 4. This line is tangent to both G and H at 2. So you're given this point 2, 4, and then you're told that this equation is tangent to both of those graphs at 2, 4. All right, so that's the thing that they gave us. Off we go. Letter A, find h prime of 2. All right, this is an incredibly easy question. And it's another one that's like, hey, wait, is that really it? A derivative means slope of a tangent line. So when they say h prime of 2, you want the slope of the tangent line at 2. Well, hey guys, this is the tangent line at 2. So what's the slope of this line? That's literally all that they're asking you for. It's just like checking that you know what a derivative is, basically. So hey guys, what's the slope of this line? I know it's not written in a really great format, but if you were kind of like to multiply this all out and make it mx plus b, yeah, good. The slope is 2/3. And that's it. That's the answer. You're done with part A. That's all that they're asking for. So that's another situation where, like, if I was sitting in your seat, if I was like the student, I would almost like second guess myself on that one. Don't do that. That's all that they're asking there. That's all you need to do. All right, part B. Let A be this function, 3x squared times h of x. Write an expression for A prime, find A prime of 2. All right, that is easy enough. We're going to do the derivative and then we're going to plug in 2. I actually like that question. I feel like you don't have to guess what they're asking you for. They come right out and tell you, do the derivative, plug in 2. I feel like a lot of this exam is interpreting what on earth the directions are saying. And I feel like that one is really straightforward. So I kind of like it. All right, we do need a product rule. It's 3x cubed is the first function, h of x is the second function. All right, so you have to remember the product rule. Product rule is the first function times derivative of the second, that would be h prime of x. So first times derivative of the second plus the second times derivative of the first, which would be 9x squared. All right, so there's that derivative. Now we're going to plug in 2. So 2 cubed is 8 times 3 is 24. All right, now we need h prime of 2, which we did right there. It's 2/3. It's the slope of the tangent line. Do you remember when we did last class where you had to find like f prime of something, but they had a graph? And so we did the slope at that point. It was, derivative means slope. All right, h of 2, they tell us h of 2 is 4. And then plugging 2 in here, 2 squared is 4, 4 times 9 is 36. Leave that alone. You don't have to do anything to that. That is the answer, and then you just move on. All right, so parts A and B were actually not too bad. The rest of this is going to be a little crazy. So here, let me tell you what the points were for this. You get a point for part A, you get 2 points for this derivative, and then you get a point for plugging in 2. Like I keep saying, if you can get about 4 out of the 9 points for each of these, you're in good shape. So if you even got that far and parts C and D were kind of a wash, you'd still be in good shape, right? Now I'm not saying totally ignore these. We're still going to go over them. I'm just letting you know these do get a little bit crazy. And if you at least got parts A and B, you'd still be good. I'm just trying to give you like a little pep talk, just confidence boost. Right, so part C, they give us this function, or the function h satisfies this. It is known that if we do limit as x goes to 2 for h of x, we can use L'Hopital's rule. What that means is this limit goes to form 0 over 0. For L'Hopital's rule, it's going to go to 0 over 0. So let's write that down. If we try to do limit as x goes to 2 of this, sorry, it takes a minute to write it down there. That is going to go to form 0 over 0. And remember, you can't write equals 0 over 0 because it's technically not a number. It isn't a value. So that's why I use the arrow and write form 0 over 0. So you're not linking together two things that aren't equal. I don't know. It's a nitpicky thing. But anyway, if we can do L'Hopital's rule, it means that this is going to go to form 0 over 0. And they're asking us to use that information to find f of 2 and f prime of 2. So let's just see where this takes us. I know that's what we're trying to get, are those two values, but let's just kind of see where this takes us here. So if we plug in 2 for x, we should get 0 for the numerator and 0 for the denominator. Well, if you plug in 2 here, 2 squared is 4, minus 4, that's going to give you 0. The same thing is going to happen in the denominator. So if we plug 2 in here, we would have 1 minus f of 2 cubed is going to have to equal 0. So if we plug in 2 for f of x, this is going to equal 0. And then we're going to solve this for f of 2, and we'll have the first thing that they're asking us for. So I'm going to subtract over the 1. And then the negatives are going to cancel. And then to get rid of the cubed, you're going to cube root. Well, the cube root of 1 is 1. So we get f of 2 equals 1. So that was the first thing that they were asking for. That wasn't like so awful, but they just slam you with information here. It's a little bit of overload. Also be aware, this is question 6 on the free response non-calculator. This would be like the last question on the test. You would get to this one after having already been there for 3 hours and be exhausted. So this exam is a marathon, not a sprint, okay? So we found the first thing they were asking for, f of 2 equals 1. All right, so now we're gonna actually do L'Hopital's rule because we need f prime of 2, and so we're gonna have to do derivatives for these. So limit as x goes to 2 of this. Again, I'm just recopying that. That is going to equal limit as x goes to 2 of the derivatives. You have to show, it says show all the work that leads to your answer. You have to link these two things together to show L'Hopital's rule. So we're going to do the derivative of the numerator and denominator. That's what L'Hopital's rule says. Do the derivative. It's not a quotient rule. You're going to do the derivative separately. So numerator is 2x. Denominator, derivative of 1, that's a constant, so that's going to be gone. This is going to be a chain rule. You have to bring down the 3. We'll have negative 3 f of x squared, and then you have to chain on the derivative of the inside function, which is f of x. So again, the 3 came down, it dropped to a 2, and then you chain on the derivative of the guts of the problem. So that's L'Hopital's rule. Now they did tell us in a roundabout way what this is going to have to equal, and it's going to have to equal 4 because this function is continuous, and they tell us the point 2, 4 is on that graph. So when we do limit as x goes to 2 of all this mess, it's going to have to equal 4. And that, I think, is one of the trickiest parts of this problem, is realizing like, oh, I'm going to have to set this thing equal to 4. Because I feel like so far, like if you realize this would go to 0, well, you can set that equal to 0 and solve. And if you know L'Hopital's rule, you're going to be able to do the derivatives. But remembering to set that equal to 4, I feel like is where this one kind of like, I feel like that's tough to get that. All right, so now we're going to plug in 2 for x, set this equal to 4, and we'll solve it. So if you plug in 2, you're going to get 4 over, down here, we'll have negative 3. Now we're plugging in 2, so it's f of 2 squared. Well, f of 2 is 1. So that would be 1 squared, and then times f prime of 2. Again, I just plugged 2 into all that. I'm going to write this 4 as 4 over 1, because what's going to happen is if you cross multiply here, the 4s are just going to cancel out. So essentially, you can just set this equal to 1, just setting the denominators equal here since the numerators are the same. So 1 squared is just 1. This would be negative 3 times f prime of 2 equals 1. And then you would divide over the negative 3. So negative 1/3 for that. That was really tough. I feel like the L'Hopital's rule I would have gotten, but like as a student, knowing to set that equal to 4, I mean, I realize they set it up here, but catching that is, you know, you gotta be on your toes. And again, you'd be exhausted by the time you even got to this part. All right, so points for this one. I'll just do the points as we go along since I told you them for A and B. You get a point for the f of 2 equals 1. You get a point for doing L'Hopital's rule. You get a point for setting it equal to 4. And then you get a point for this answer. All right, that was part C. Again, I might have gotten these two, but I feel like these 2 points were pretty hard. All right, and then part D is a lot of writing and a lot of like symbols and notation. So just buckle up for this one. Okay, because we're gonna do a bit of writing here. This is sort of like an essay question, and you're gonna be so mad when we get to the end of it. All right, so just hold on a second. All right, it is known that g of x is smaller than h of x on this interval 1 to 3. Let k be a function satisfying this. So k is in between. This is going to be your squeeze theorem, which you probably don't remember because we did it back in unit 1, but I did teach it to you. This is squeeze theorem. This function is getting squeezed in between the other two on this interval. Is k continuous at 2? Justify your answer. All right, so for a function to be continuous, you have to have 3 things. There has to be a point, there has to be a limit, and they have to agree. And I like that they're testing on continuity. I think that's fine, but adding this into the mix is just kind of a lot. I think you guys should know the definition of continuity. If you've made it through calculus, you should know definition of continuity. You have a point, you have a limit, they agree. But this one's kind of a lot. So let's start with the point. Since, and again, this is going to be like you're explaining something here. This is sort of like a proof. All right, so since g of 2 is smaller than k of 2, which is smaller than, and we're trying to prove continuity at 2. That's why I'm plugging in 2 for all these, is smaller than h of 2. All right, so since that's all true, and we know that these two both equal 4. They told us back at the beginning of the problem that g of 2 is equal to 4 and h of 2 is equal to 4. So if these are both equal to 4 and k of 2 is squeezed in between them, so since this is all true, k of 2 equals 4. That's your conclusion there. So we have a point. Now we have to prove that there's a limit. Now they told us that g and h were differentiable. Well, that means they're also continuous. You have to mention that, right? So since g of x and h of x are differentiable, and again, I would write it out on the AP exam. They are also continuous. And so limit as x goes to 2 for g of x is 4, and limit as x goes to 2 for h of x is also 4. If they're continuous and they have these points at 4, that means their limits are also 4. Limit as x goes to 2 for both of them is going to give you 4. Again, it's a lot of writing and a lot of notation, not necessarily a difficult concept to understand. If they have a point to 4, they have a limit to 4. Limit as x goes to 2 is going to be 4 for both of them. And so, there's a lot of and so's here. I guess you can phrase that however you want. And so now we're going to show that k is squeezed in between them. And so it's basically going to be the exact same thing that I wrote here, except instead of points, we're going to do the exact same thing for limits. Limit as x goes to 2 for g of x is smaller than limit as x goes to 2 for k of x, which is smaller than limit as x goes to 2 for h of x. Again, this is not difficult to understand that k is in between the other two. It just looks scary with all the writing. And again, we said that both of these ones on the ends were 4. So if k is squished in between them, then limit as x goes to 2 for k of x is also 4. So we have a point for k to 4. We have a limit for k to 4. And so you can conclude k of x is continuous at 2. Again, I feel like mentally understanding that is not all that difficult. Hey, k is squeezed in between the other two functions. They both have points to 4 and limits to 4. So k also has to have a point to 4 and a limit to 4. It's just to write all that out is a lot. And I told you you'd be mad at the end. If you've been paying attention to how many points everything else is worth, and you know that all the response add up to 9 points, this entire explanation was worth 1 point, which just infuriates me. But it's kind of good because if you didn't get it, you only lost out on 1 point. It's not like it was worth a whole lot. But anyway, yeah, one point for explaining all of that.